Now we can start solving the first question. You are told that a wire fixed at one end extends by 4 millimeters when a load of 20 newtons is suspended from the other end. Then you are told, determine the load that would cause an extension of 1.5 millimeters on the wire. Many a times, students will rush to just relate, but there is the concept that is first being tested. So the first thing that you need to take first is that you first get the spring constant of this wire. Therefore, you will say that the constant will be given by the force over the extension. So our force is of 20 newtons. Then our extension here is of 4 millimeters. So remember to work this one while it is in SI units. So you divide this one by 1,000. So it will be 0.004 meters. Now you can substitute the values in this equation, where you can say our K will be given by a force of 20 divided by 0.004. Then in this case, from computing, then you'll get 5,000 Newton per meter. That will be the spring constant. Now, in the second case, you are provided with the spring constant as 5,000 Newton per meter. Then we have our extension as 1.5 millimeter, and this one is equivalent to 0.0015 meters. Then what we are asked is, what will be the load? So what will be our F? That is the part that we are being asked. So we'll say from this equation, then force can be given by Ke. Where we'll say our force is given by our 5,000 Newton per meter times an extension of 0.0015. And this one will land us to dash Newton. So after computing, then you're going to get 7.5 newtons. You're also supposed to be having the calculator with you, so that in case there is variation, you'll be able to say. If we are together at that point, you can just indicate so that we can proceed to the next question. Thank you. Question 2. It reads, the, the three springs shown are identical springs and have negligible weight. Then you are told the extension produced by the system is 20 centimeters. Then you are told determine the spring constant of each spring. Then we are having this diagram over here. So you can copy the question. We can still go on. We can solve. So in this case, we'll say the spring constant for this one is just K. And because this upper part, we are having springs in parallel, then we expect then to be the combined spring constant to be Nk, and this one will be 2K. Yeah. Now we are supposed to find an equation where we can get to production of an extension of 20 centimeters. Therefore, originally or basically, we know that spring constant is given by force over extension. So if we need extension, then it will be force over K. We are having two parts, the upper part and the lower part. So upper parts, we expect to produce, maybe you can give it E1 to be the force over 2K. Then you can call this one maybe to be equation 1. Then the lower parts, we said is producing E2, which will also be given by force over K. Then we call that one equation 2. Then you say equation 1 plus equation 2, we are supposed to lead all the way to production of 20 centimeters. Therefore, let's look at E1. So is kama kusema E1 plus E2 is supposed to be given as 20. Then you replace, that is F over 2K. So you ask yourself, what will be the force acting on the upper part? So you can see we are having 20 and another 20. So the total force there will be 40. So you can say 40 divided by 2K, which is giving us E1 plus E2, which will be a force, the force acting on this spring. It is 20, a single 20 newtons. Then you divide by the spring constant K. And this one is supposed to be giving us 20 centimeters. But for my case, I want to convert these 20 centimeters. Okay, it is optional. You can use it in 20 centimeters, or you can use it in meters, which will be 0.2. So if we go for 20 centimeters, we'll just equate like this. And just remember that this one is in centimeters. We keep moving. So in simplification, this 40 over 2K, E2 inaweza kata hapo juu. So we'll have 20 out of K plus 20 out of K is equals to 20. So you multiply through by K. So we'll have, so you have said, multiply through by K. So we'll be having 20 plus 20 is equals to 20K. So this is 40 is equals to 20K. So now, when you make the K the subject, the formula, so K becoming the subject, the formula, then we shall be having K as 40 divided by 20. And in this case, we are going to get 20. But what will be the 20? It will be 20 Newton per centimeter. Sorry, it's supposed to be 2, eh? Supposed to be 2. 2 Newton per centimeter. So, in other words, in SI units, 2 Newton per centimeter will be the same as 200 Newton per meter. So, just multiply by 100 or you divide by 0.01. So, that part will be solved. Thank you. Now, without taking much time, we can, okay, I know we have those people who are doing some copying. So maybe you get a minute, you write down, then we can proceed. So just take a minute, you copy. As you copy, you can also start copying our question 3. So you copy together with question 3. I hope you're done with the copying of question 3 together with the solution of question 2. Then now we can have it. An object of weight 20 newtons is attached at the end of a spring, causes an extension of 0.5 centimeters on the spring. Determine, that is A, the spring constant of the spring. You are awarded 2 marks. Then you are told part B, determine the weight of an object that would cause an extension of 0.86 centimeters. So now we can solve this one. Okay. You are provided with a force of 20 newtons. We have an extension of 0.5 centimeters. If we convert this one into meters, then it is going to become 0.005 meters. We know that spring constant is given by force over extension, and therefore our force is of 20. Then you divide by 0.005 from the computation. That is like 20,000 divided by 5, which is supposed to become something like 400. So let me confirm. It is 4,000. So our K is 4,000 Newton per meter. Part B. We have now a spring constant of 4,000 Newton per meter, and we have an extension of 0.0. This is supposed to be 0.0. 0.86 centimeters. In SI unit, it is 0.0086 meters. So what we are being asked will be the load, which will be F. So F will be given by KE. So 4,000 multiplied by 0.0086. You're going to get your answer here in newtons. So this one becomes 34.4 newtons. We have our question 4. The spiral springs shown are identical. Each spring has a spring constant of 300 Newton per meter. So this is the setup. Then you have to determine the total extension caused by the system. This one we are going to use different ways. So I can say case 1, we can say the upper part will be having a combined spring constant of Nk, and they are 3. So we shall be having 3 times 300. We get 900 Newton per meter. That will be the combined spring constant at the upper part. And at the lower part, we shall be having 2 times 300. And this one will be 600 Newton per meter. Now we can find E1 at the top and E2 at the bottom. So E1 will be given by force over Kc combined. That is the spring constant combined yenye nakuonyesha hapa. So it will be a force, the force acting is of 90 divided by 900. And in this case, our E1 will become 0.1. 0.1 meter. Then we can go to E2, will be given by force of a combined spring constant at the bottom. And this will be 90 divided by 600. And this gives me 0.15 meters. Then the total extension, E total, will be given by E1 plus E2. And this is 0.1 plus 0.15. And the total of this one will be 0.25 meters. Now I want us to move to option 2 or case 2. So our case 2 or option 2, then allow me erase something here. So now can go for case 2. We say picking one spring, since all of them are identical, and we say that this extension produced by one spring will be the force over K, and this is a force of 90 over the spring constant of 300, and this gives me 0.3 meters. So taking or singling out to have one spring, namna hii sasa, same now this is the 90. Sasa hii ikiwa moja, it is going to extend by 0.3 meters. Then now come to the relationship of extension in series in a parallel. So we say the extension for this one, for the lower parts, they are two in parallel. So they are going to produce a half E. Then the upper parts, they are three, we shall have a third of E. Then we say that E total for the system will be given by a third of E plus half of E. So E total hizi ukiongezganisha zote I can see somebody who is very serious over there. A third E plus from your calculator, can you let me know what is a third plus half? So this one is going to give us 5 out of 6 E. But we have our E is 0.3 meters. So E total will be the same as 5 out of 6 times 0.3. And we are going to get 0.25 meters. This is a confirmation of the first answer that we had got. So we have those two methods. You single out to have one spring, or you work all of them as a unit. Okay. Now we can proceed to question 5. It reads, the figure below shows identical springs. The extension produced on the system of the spring is 40 centimeters. Then you are told, determine the spring constant of each spring. So you can look at the setup the way it is. So now we solve. So the total extension is 40. And you can see we are having two weights here. So we take the upper part. We have two springs and they are in parallel. So we expect them to have a combined spring constant of Nk. And in this case, it will be 2K. Then this one will have a spring constant of K. So the whole formula where we say K is equal to F over E, then E will be given by F over K. So now we say the upper part will produce extension of E1 and the lower part will produce extension of E2. So we can find E1. E1 will be given by our force that we are given. We have 10 and 10 here, so a sum of 20 newtons. Then you divide by the spring constant of these two. We have said it is 2K. Then our E2 will be the weight acting on this spring is only 10 newtons. Kwa hivyo hapo tuko na 10 newtons divided by K. Then you know that E total is equals to E1 plus E2. So this is 1 and this is 2. So 1 plus 2, we are supposed to get 40 centimeters. 20 nalo. So 20 out of 2K plus 10 out of K, they are supposed to be giving us the total extension, which is 40 centimeters, which is 40, niandike tu kumbali, it is in centimeters. So anything that you are going to get there, you shall be having spring constant in Newton per centimeter. We can divide it through by 2 in the first part. So we can get, I don't like canceling, but anyway, by 2, 1, by 2, 10. So we can have 10 divided by 2, by K. Plus 10 divided by K, you get 40. You remove the K's here by multiplying across by K. So you have 10 plus 10 is equals to 40K. This will be 20 is equals to 40K. So K will be the same as 20 divided by 40. This one will lead us to 1, that is half. So it will be 0.5 Newton per centimeter. .5 Newton per centimeter. And this one is equivalent to, in SI unit, it will be 50 Newton per meter. Can get to question 6. States the Hooke's law. It states that for a helical spring, or any elastic material, the extension is directly proportional to the force causing it, provided that elastic limit is not exceeded. A law remains to be a law. A law never changes. Sheria ni sheria. You can write this, and some part of this so that I can show you the diagram. So can I respond to part B? You are asked to define the term spring constant. And this one is defined as is a measure of a spring's stiffness. The measure of a spring's stiffness. C Roman 1, state factors that determine spring constant. We know that from the formula K is equals to force over extension. So these two factors will lead us to the spring constant. So we have the stretching force and we have the extension. We have the extension. Roman 2, we have a graph which is here. It shows the relationship between force and extension of a given spring. Then we have part A, B, and C. Then you are all told, explain part A, B. Let's be careful, please. You are told to explain AB. AB, you are supposed to explain it in terms of what the gradient or the slope of the graph is supposed to be giving us. So we expect to have spring constant as the slope of this one. So if you look at these parts, then you can say that the spring constant is uniform. It shows a uniform spring constant. Or can say it is obeying Hooke's law, like that, or is obeying the Hooke's law. Then at this point, where we are having some irregularities, then we say the elastic limit is exceeded, leading to deformation. Leading to deformation. Roman 3. State the significance of the gradient of the graph between points A and B. Ndio hii tulikuwa tumesema hapa, Hooke's law. I hope for those who are copying, they have finished copying. Now I can go to part D. Of the question. You write it down so that you can solve. The pointer of a spring reads 32 centimeters when there is no load. When loaded with 120 grams, the pointer reads 38 centimeters. When a pan containing 210 grams mass is loaded onto the spring, the pointer reads 48 centimeters. Then you have to determine the mass of the pan for marks. So we can start looking at the question. So we are given a load of 120 grams, and this is equivalent to 0.12 kg. Then the extension, it is producing, it will be of 38 minus 32. And you're going to get 6 centimeters or 0.06 meters. For this load, we are given in kilograms. So we can say our force or weight will be given by mg. So it will be 0.12 times 10 newtons per kg, get 1.2 newtons. Now from there, we'll be able to solve. So the first thing, we get the spring constant. So the spring constant will be given by the force over extension. And we have got a weight of 1.2 against an extension of 0.06. And this one will then definitely lead us to 20 Newton per meter. That is, can call this one our case 1 because we are having 2 cases in the same question. So case 2, we're having a load of 210 grams, which is the same as 0.21 kg. And we can convert this one into weight. So the weight will be mg, so 0.21 times 10, and it will be giving us 2.1 Newton. Remember this one, it is inside a pan. It is inside a pan. So total load will be 2.1 newtons, maybe plus something like, let's say, P for pan. So this one is pan. And these one are all in newtons. So from this one, we have the spring constant of 20 Newton per meter. And we have an extension of 48 minus 32. And this is giving me 16 centimeters. And this is equivalent to 0.16 meters when you convert. So you are being asked about the force. Okay, you can just say the force is 2.1 plus P Newton. So we want the P. That is what we are supposed to be looking at. So from the formula, F is given by KE, then 2.1 plus P will be the same as 20 newtons times an extension of 0.16. So now it will be 2.1 plus P is equals to ile ingine inatuletea this one is giving me 3.2. So now you open up 2.1 plus P is equals to 3.2. So P becoming the subject formula, you take this one on the other side. So it is 3.2 minus 2.1. You get 1.1 Newton. But the question was asking about the mass of the pan. So mass can be given by the weight over G. So 1.1 divided by 10, you get 0.11 kg. And this one is equivalent to 110 grams. So showing that one, then definitely be on the safe side. So I'm waiting you finish copying. Then you can indicate so that we can open the next question. Our very last question. can look at the last question. We're told that the table below shows the results of an experiment to study the properties of a spring. Then we have the questions that are there. The first one, you're told plot a graph of force against extension, and then you find the spring constant. Kindly take a minute so that we can, in case you are having a graph, can draw together. Na tafadhali ukimaliza, you let me know kama mimi nimemaliza. Okay. This class, for those who might have been left out, then we shall be having the same presentation from our YouTube channel as sending grades at exactly 5 or 5 p.m. today. So ensure once you get the link, then you might follow up pole pole. So in case somewhere we rushed, utakuwa unasaidika. So if you're done with the copying, then you can go to the graph so that you can draw it. This is my graph. I don't know if it is clear. You have somebody who has been left out in copying. Kindly follow speed and accuracy. I hope now you are done. So now we may proceed to the other parts. So we want to draw or plots the graph of force against extension. So probably I'll pick just somewhere. The grids are not that much feasible, but next time I will improve on the kind of grid that I'll be using. Of them appear to be the same. I'm wondering where will I place So taking that one as my x-axis. Like this. Then you can see we are having force in newtons. Then on the other side, we have extension in centimeters. Then at 0, 0, the first thing is identify the scale. After plotting the axis, you identify the scale. I can see from your phones or from the devices that you are using, this thing is appearing to be totally different from what I'm having. But I'll just let you draw yours in your own free time. So maybe I'll just guide. So I can say on the y-axis, I can just count 5 boxes. 1, 2, 3, 4, 5. 5, 6, 7, 8, 9, 10. So I can say that is now my 10. One, two, three, four, 5, 6, 7. 1, 2, 6. So that becomes my 20. My 4, my 30, sorry. So that is my 40. Then on my x-axis, we are having 0 to 8. So I can just count 5 boxes to be 2 units. 1. So this one will be my 2 centimeter. 2 centimeter, 3, sorry, this is supposed to be 4. Four, 6, 8. And probably that one can become the 10th. So at 2, I'm having 10. So that is the point. At 4, I'm having 20. Then at 6, I'm having 30. You can just follow my dots venye inaenda so that I can identify the points. Then at 8, I'm having 40. Like that. So now, hello? Hello? So now we are supposed to join these 4 dots so that you can form a straight line. I hope now it is feasible from your screens. Then the question that were there was the first one, you plot. So we can now add the plotting. So drawing the axis, you get 1 mark. Finding a suitable scale, you get another 1 mark. Plotting, you get another mark. And then define that it is a line or a curve and join it together. Then you get the other mark. Then you get 4 marks. Then you are told find the from the graph get the spring constant. So in this case, you just get the gradient. So just identify 2 points. And you show them. Then you say you're having a change in y and a change in x. So my gradient will be change in y over change in x. So from this point, it will be 30 minus 20. And the change in x will be from 6 This is 6 minus 4. So this brings a total of 10 divided by 10 divided by 2. So it will be 5. Solving this one will be 5 Newton per centimeter. Remember the x-axis, we are using centimeters. So now this one can be written as 500 Newton per meter. So guys, let's appreciate for the lesson. You can see maybe we are having a net issue. Thank you so much.